morning. In this video, we are just going to talk about the very beginning of goodness of fit tests. So we're in the beginning of chapter 11. This video is very short and sweet because we're just talking about some of the basic rules. And so first off, we have the intro to chi-square distribution. So that's pronounced chi, not chi. Chi like Kyle for short. Short. Anyways, you know what I'm saying. So chi-square distribution is just a hypothesis test with very specific formula. And we're not even going to get that far today. We're just going to talk about some characteristics that are unique to chi-square distribution. So you have these 5 things written right here on your notes. And I'm going to go into each one of those in a little more detail. So let me switch to my pictures. And so the first one is that the curve is always non-symmetrical and skewed to the right. So here's 2 examples. Here's something with the degrees of freedom of 2, and we'll talk about degrees of freedom in a minute. We have the degrees of freedom as 2, is just kind of almost like a graph of like 1 over x or something. It looks kind of like that, but it is skewed to the right, which means it pulls to the right, the tail goes to the right. And then this one has a degrees of freedom of 24, so a little higher degrees of freedom. And you'll notice that it has a normal-ish distribution, but it still has that tail out to the right. So chi-squared curve starts at 0 on the horizontal axis. And so one thing that's different about this is that we have the y-axis in the picture because it starts at 0. It starts right here at 0, and then over here on the left, it starts at 0. So we haven't really worried about the y-axis and the other distribution, but this one, it starts at 0 and it extends to the right indefinitely. That's where we're getting our skewed right. And as it extends to the right, it approaches but never touches the horizontal axis. So it kind of looks like it touches here because it gets so super duper close, but that's important just to note that it never touches the horizontal axis, which means it's always above and therefore always positive. The population mean of chi-square distribution is just to the right of the peak. So since this is skewed, that means the mean is a little bit bigger than the median. And so it's just, so here's the peak right here. Instead of mu being right in the middle, it's to the right. The total area under the curve is equal to 1. Even this guy over here. The total area under this curve is 1. The total area under this curve is 1. The total area under this curve is 1, which means a couple things. 1, we can do a lot of things that are like the normal distribution, those kinds of ideas. And number 2, is very similar to probability because of the equaling 1 thing, just like we had before, ever since chapter 6. Okay, and last but not least, as the degrees of freedom increases, the curve looks increasingly like a normal curve. And so I mentioned that. Let's just go back and look at that picture again. Up here, degrees of freedom is 2. Doesn't really look normal at all. In fact, the left side is going up. But just increasing from 2 to 24, we have already looking more normal. It's just skewed to the right. And the bigger this is, the more normal we're going to get. Okay, so starting off, again, we'll get to degrees of freedom in a minute. Would you guest star my video? You want to say hi? No. He doesn't want to say hi. Okay, so it says, which of the following does not apply to a chi-square distribution? So you're going to see a couple questions like this where you're going to just refer back to this list. So it says the curve is always skewed to the right. Well, it is always skewed to the right. It says that up here in the top, skewed to the right, skewed to the right. So this is true, but that means it's not the answer because this is which one does not apply. The population mean is located just to the left. Well, up here it says the population mean is located just to the right. So that would make this a right answer in that it's wrong. You see what I'm saying? It does not apply. So this is untrue right here with the whole just to the left business. So that's why it's the right answer. All right, next up, there's an infinite amount of square curves. yeah, as we keep increasing the degrees of freedom, then we have a different chi-squared curve. And then finally, the total area. Oh, wait, so let me get my. And the total area under a chi-squared curve is equal to 1. That is also true about this. So that can't be the answer for something that says does not apply. Okay, now we're going to talk about degrees of freedom. And we've talked about degrees of freedom just very, very briefly because they haven't really played into what we needed to calculate. But it will come up in 11 and it will come up in chapter 13. And so the degrees of freedom in this is going to mean one less, but let me just write this out. I'll just write it over here. So degrees of freedom let me write correctly, is the number of categories minus 1. That's going to be our formula. So that means our formula is going to be k minus 1. Okay, let's go back a second and talk about what number of categories even means. So going back to this, my picture, I just want to give a few examples that we have here. This is, have you ever wondered if lottery numbers were evenly distributed or if some numbers occurred more frequently? How about the types of movies people preferred across different age groups? So this is where we're going to use the hypothesis test, but not using normal distribution, which is where we're getting chi-squared from. Okay, so in this first example, if we're talking about lottery numbers, each digit, well, I guess it depends on the type of lottery. Let's just say, okay, I can't even make up an example because there's so many different kinds of lotteries. We'll talk about categories in the next video much more specifically. Today, we're just going to practice degrees of freedom. Okay, let's go back. So this first one says, for a chi-squared curve with 8 degrees of freedom, weird way to write it, I sometimes forget the proofreading, find the chi-square value for alpha equals 0.05. Okay, so we have chi-squared. Did I show you the symbol for that? It is a chi, which kind of looks like a curvy X, and then a square. So the chi-squared distribution with 8 degrees of freedom. So our degrees of freedom are over here. We go down to 8, and then it says the chi-squared value for alpha equals 0.05. This number below the chi-squared is alpha. We don't do anything to the decimal. We just copy it exactly. So that would put us in this category. This is different than this far one because there's too many zeros. So if it is looking for the 8 degrees of freedom with alpha 0.05, this is our number right here, 15.507. And that's it. You just copy it down from the chart. Okay, last one. We have a chi-squared value with 14 is the degrees of freedom. Find the chi-squared value for alpha equals 0.01. So 0.01 is this fourth column with the 0.01 in the alpha spot. Degrees of freedom is 14. So there we go. And I'm just going to add a little, now, you know what? We're going to talk about how to calculate the degrees of freedom when we're not given it in the next video. This is just basic. Here's a few rules about it. Here's a chart. We'll get into all the details in the next video. So, like I said, short and sweet. If you have any questions, shoot me an email. Otherwise, I will see you in the next video. Bye.